Hi there, it's Miss Chinnick, and I'm going to work some problems out for you on your electricity math practice page. We'll start with the Coulomb's law questions. Coulomb's law is the big equation that you will use. F equals K Q1 Q2 over D squared. And in that equation, I'm not going to ask you to plug in the actual numbers for K's and Q's and D. I'm just going to ask you to do the rule of ones and solve for proportional changes. So number one has two balloons. They're held 1 meter apart. How will the force change if the charge on both balloons is reduced to half? You will take F equals, and then you'll plug in a 1 for every number that doesn't change. So the K stays the same. Both of our charges are 1/2. And the distance is staying the same. So this will be 1/4 the force that it was before. 1/4 F. I'm just making sure my video, everything's staying in frame. I'm shooting outside today because it's pretty and it's bright. Our next equation, our next question, we have two packing peanuts. They become attracted while in a box. What happens to the force of attraction if they're suddenly moved 3 times as far apart? So that's only a change to the distance part on the bottom. That's going to be F equals 1 times 1 times 1 on the top, and then on the bottom it's 3 times as far apart, so we're going to put a 3 in and then square that 3, because everything we do to the distance proportionally you have to square, since it's a d squared on the bottom of the equation. That ends up being 1/9 the force. The last Coulomb's law question has us taking two spheres that are 2 meters apart. We're changing the charge on both spheres. We're doubling it. So we have a doubling of the charge. And the distance is reduced to 1 meter. So that you just have to compare the two. That's 1/2 of the distance. So this one will be a little more complicated. We'll have changes on the top and the bottom. We have 1 for K. We're doubling both charges. And then we're going to cut the distance in half. We have to square that. So you end up with 4 on the top and 1/4 on the bottom, which is the same as saying 4 times 4 over 1, which is 16 times the force. Again, just making sure you can see everything I wrote in the video. All right. Our next set of questions has to do with electric field. The equation for electric field that I will have you use is E equals the force over the charge. E is electric field, F is force, and Q is charge. A dust particle floating near an old TV is found to have a charge of plus 0.055 coulombs. What force will it experience if the TV has an electric field of 1.2 newtons per coulomb? This is my charge, 0.055, so that I will label as Q. And the electric field is 1.2 newtons per coulomb. These questions are always easy to pick out because they have electric field written in them. That tells you which equation you're supposed to use. We are looking for the force. So if I use my E equals F over Q equation, I'm going to plug in 1.2 equals F over Q, which is 0.055. To solve this equation, I'm going to multiply both sides by 0.055. That will cancel out this side, and we end up, when we multiply those two together, we end up with 0.066 newtons. The second electric field question, a piece of plastic wrap with a charge of 0.0113 coulombs experiences a force of 0.18 newtons. Those are our two givens. That's Q for the charge, 0.0113 coulombs, and the force is 0.18 newtons. And the question is looking for electric field. That's the E. When we plug this into our electric field equation, E equals 0.18 newtons over 0.0113 coulombs. We get 15.9 newtons per coulomb. All right. I'm trying to make sure that that's not too bright. I hate to record this video and then have to reshoot it. Electric potential questions. Remember, potential is voltage. Our equation for electric potential is V equals potential energy over Q. And the V might be referred to as voltage, or it might be referred to as electric potential in our question. Number 6, we have a particle with 2 coulombs of charge and experiences a potential of 150 joules. How much electric potential energy does the particle have? So we have 2 coulombs of charge, and then we have oh, you know what? I meant to tell you guys I have a mistake. That's supposed to be a V. I'm so sorry. That's my potential. I accidentally wrote joules, and I believe that I forgot to tell you that in class last week. I apologize. If that one was confusing, that's why. So make that change right there. That's supposed to be voltage. I'm asking you for potential energy, and that is the PE. So this is our potential. V equals 150 volts. Hopefully that will make this question a little bit easier. Our equation over here, V equals PE over Q. So if we plug in what we know, 150 equals PE over 2. And we just multiply both sides by 2. That cancels out on this side. And our potential energy is 2 times 150, which is 300 joules. In number 7, Fred is going to hold a small negatively charged sphere near a large negatively charged Van de Graaff generator. If the sphere has a potential energy of 1.8 joules, that's written correctly by the way, and has a charge of 0.004 coulombs, what voltage does it experience? So this time it's using the word voltage, which makes it a lot easier to plug into our formula. We're given a potential energy of 1.8 joules, and we are given a charge, Q, of 0.004 coulombs, and it's asking us to find V. V equals PE over Q. And when you take 1.8 divided by 0.004, you get, hold on, not that. You get 450 volts. Oops. Sorry. Wiggling things around here, trying to be sure I get everything in the frame. Our next equation is for Ohm's law. Our Ohm's law equation is I equals V over R, which will by far be the most heavily used equation in this unit. In number 8, when the human body's dry, it has a resistance of 120,000 ohms. That is our R. It's a big number. How much current flows through Bob when he touches an exposed wire on a 120 volt light switch? So we are given the voltage, and we are looking for current. Remember, current is I. I equals V over R. So 120 volts over 120,000 ohms. That is 0.001 amps. Number 9. What voltage was imposed across a 15 amp fuse that has a resistance of 0.053 ohms? This right here, I know it has a fuse and it talks about voltage imposed. There's some weird language in here, but the question is looking for voltage. And this 15-A means a 15 amp fuse, so the current would be 15 amps. Resistance is pretty easy to pick out. So we're going to use I equals V over R. This time we're given the I. 15 equals V over 0.053. So to get our V, we need to multiply those together. We're going to multiply both sides by 0.053. Oops, I wrote that a little weird. That'll cancel out here. I'll multiply it over here. So V equals 0.053 times 15, which is 0.795 volts. Number 10. What is the resistance of a light? Oh, I wrote the word light twice. Of a 3 volt light bulb that has 0.5 amps of current running through it. So the 3-V light bulb means that the voltage is 3 volts. And then 0.5 amps of current, that's pretty easy to pick out. We are looking for R. I equals V over R again, and this time we're going to solve for the R, which is probably the more challenging mathematic part. When we're solving for the variable on the bottom of the equation, we have to multiply both sides of the equation by that variable in order to get it out from under the denominator. A lot of people mistakenly multiply the 3 and 0.5 together, or mistakenly say 0.5 divided by 3. If you just remember to move that R over to the other side, it'll be easier to see what you are actually supposed to do. Now that we have the R on this side of the equation, you can see that you actually need to divide the equation by 0.5 on both sides. And when you divide 3 divided by 0.5, you get 6. That is your correct answer for number 10. Just checking to make sure I'm still recording. I am still recording. Awesome. Oh, wrong one. We're flipping to the back. Okay. On the back, we'll start with the power questions. These are the ones I did not have a chance to go over in class. So our equation for power is P equals IV. Power is equal to current times voltage. That's the only equation you need to know. Sometimes you'll have to do two-step problems on these, but number 11 and 12 are pretty straightforward. How much current does a 100-watt lamp draw when connected to 120 volts? 100 watts. Watts is the unit for power. So P equals 100 watts. And we have 120 volts. That's our V. We are looking for current. If we plug in to our equation, we'll have 100 watts is equal to I times 120 volts. We will divide both sides by 120, and we will get a current of, hold on, I'm looking at my key. The current's going to be 0.83 amps. Number 12, if part of an electric circuit dissipates energy at 6 watts. So that sounds a little scary. Their energy dissipation and circuits and blah, blah, blah. Don't worry about all that scary lingo for electricity questions. Just look at that unit, 6 watts. That'll tell you that we are given the power. It draws a current of 3 amps. We are given the current. And we are looking for the voltage. So we'll use our P equals IV equation. We'll plug in 6 equals 3V. And we will divide both sides by 3. And that will give us a voltage of 2. I didn't even need a calculator for that one. The last power question is a little bit more involved, and you'll know what to do if you just label what you've been given. What is the power? So they're looking for P dissipated by a 0.33 amp bulb. So the amps is current. That has a resistance of 15 ohms. Now this is where some people go wrong, because they label this other number as our voltage because they think, well, we're just going to take I times V, so they multiply these two numbers together. But you can't do that and get the right answer because this is I and R, not I and V. And there's not an equation that I'm giving you that has these two together. You can derive one if you feel like it. But what we really need to do is take those two things and we need to find V. I, R, and V are related by Ohm's law. So our first step is to do Ohm's law to find voltage. If we plug in our current, 0.33 amps equals V times 15 ohms, then we'll find that the voltage is, we'll multiply those two together, and we'll get a voltage of 4.95. Make sure you can see that. Now we have the voltage and the current. So our second step is to use that P equals IV, and we will just plug in our current and the voltage that we had to calculate. And that will give us a power of 1.6 watts, which is the final answer. The last section is energy usage. The energy usage questions take a little getting used to because we got to change the variables around a little bit. The first two are easier. If you operate a 500 watt microwave for 30 minutes each week, how much energy is used? And this right here I put for you so you could remember what it is we have to do. We have to find our power in kilowatts, and we have to find our time in hours, and we need to multiply them together. It's a kilowatt times an hour. And I gave you some hints on this one. Change watts to kilowatts by dividing by 1,000. If you want to see me do that, 500 watts times, and then I want to convert to kilowatts. So I'm going to write a little conversion factor. You might remember this kind of dimensional analysis from physics or from chemistry. I haven't done it a ton here in this physics class. So if we do this, we'll get the watts to go away and we'll end up with kilowatts. This is the same as saying 500 divided by 1,000, because 500 times 1 over 1,000 is 500 divided by 1,000. The other thing you can do is just take 500 and move your decimal place by 3. So I'll just write that down here. If there's your decimal place, you just go 1, 2, 3 and put the decimal there. So it's 0.5 kilowatts. Then we need to get our time in hours. Now this is sometimes tricky. You have to read the question carefully. It's 30 minutes. So 30 minutes is equal to half an hour. I hope you guys can do that. That's our time in hours. That's 30 minutes per week. And the question is asking how much energy is used in 1 year. So you have to read that carefully. And then you have to think how many weeks are in a year. That's 52. And when you take a half an hour times 52 weeks, you get 26 hours in 1 year. So our final calculation for usage is going to be the 0.5 kilowatts times 26 hours. And that's going to give us 13 kilowatt hours. Number 15, just making sure you can see all that. Number 15 is an X-ray machine. It draws a 17 amp current and is connected to a 240 volt outlet. How much energy is used daily if the machine operates for 2 hours each day? So we're looking for the 1 day of energy use, and we have a time of 2 hours. So that's exciting. We've already got the hour part of our kilowatt hours, but we do not have the power part. We need to know what power is used. And because you were given a current of 17 amps and a voltage of 240, voltage of 240, we can plug that in and find our power. And when you do that, you will get 4,080 watts. We need to turn that into kilowatts. So you can do that little conversion if you want, or you can do the decimal place, hopping to the left 3 places. And either way you prefer, that is your kilowatts, 4.08 kilowatts. To get our energy usage, we just take the 4.08 kilowatts times 2 hours. And that is 8.16 kilowatt hours. The last 2 questions are a little more involved. We have a 600 watt hair dryer. It's used for 10 minutes every day. How much energy is used, kilowatt hours, in 1 year? And then we have a little bit of money added here. The electricity cost is 0.17 kilowatt hours. How much does it cost to run that refrigerator yearly? So this one's more involved. There's actually 4 little steps we have to do to get the answer. The first thing we need to do is put this 600 watts into kilowatts. So 600 watts is going to equal 0.6 kilowatts. That's our first step. Our second step is to turn 10 minutes every day into a total amount of hours per year. We've got 10 minutes. I'm going to multiply that by a little conversion factor. 1 hour over 60 minutes, or 10 minutes divided by 60 minutes, is 0.167 hours. I'm just going to make sure I've still got recording. I am not recording anymore. Oh no, I am recording. I've got 3 minutes left. I was just trying to see if I had space on my camera. I didn't have much room left on my SD card. So now we have, this is the hours per day. And if we want to get the yearly cost, we have to multiply this by the number of days that are in a year. And when you multiply that by 365 days, you get 60.83 hours each year. So now we can find our total energy use, because we have the kilowatts right here, and we have the hours right here, and we'll multiply those 2 together and we'll get our kilowatt hours. That is 36.5. And our last step, which I'll write in blue because it's hard to read everything that's going on. So the very last thing we'll do, make sure I've got time. I'm actually going to stop this for a second and I'm gonna start a new video. Okay, I'm gonna finish up this problem 16. So we were finding the kilowatt hours. We multiplied 0.6 kilowatts by 60.83 hours to get 36.5 kilowatt hours of energy usage. To figure out the cost, given the amount of money that the electric company is charging us, we just need to take our total kilowatt hours and multiply that by the dollars or cents per kilowatt hour to get our final cost for that refrigerator. So we just take our 36.5 kilowatt hours and multiply it by the $0.17 or 17 cents per kilowatt hour. What that does is cancel out the kilowatt hours and just leaves us with a dollar amount for our electricity cost. So that amount is $6.20. So I know there's a lot of steps here. There's turning watts into kilowatts, which hopefully will be a little quicker now than it was a couple problems earlier. There's turning the time into hours, which is just going to vary on what kind of time you're given. If I'd given you 1 hour, then you would just multiply that 1 hour per day times 365 days for 365 hours. This one has a part of an hour, so you just had to find that decimal place representing the part of the hour before you multiplied it by all those days in a year. There's one more question, number 17. And this is about leaving your front porch light on all the time to try to keep people from breaking into your house. So if your fixture contains a 60 watt bulb at 120 volts and your local power company sells energy at 10 cents per kilowatt hour, how much does this security cost for a month, 30 days? So let's check out what we've got. Now there's 60 watts and there's 120 volts. Which might make you think you need to use both of those numbers, but we really only need the power to figure out the cost of the energy. We only need to take that 60 watts and turn it into kilowatts. If you say 60 divided by 1,000, or if you move that decimal place 1, 2, 3 over, you're going to find that that is equal to 0.06 kilowatts. So we're partway there. We got one of our things. Next thing we need is hours. So if you are turning that bulb on, leaving it on all the time, there's our time. It's all of the time. So we're looking for how much time there is in 1 month, and then it says a 30-day month. So how many hours are in a day? 24. Hopefully this is a value you're all familiar with. How many days are in a month? Well, this month the problem says use 30 days. And if you say 24 hours times 30 days, you will find there are 720 hours in 1 month. So to get our kilowatt hours, we're just going to take our power in kilowatts. We're going to multiply that by our time in hours and get 43.2 kilowatt hours for that light bulb. What's interesting with kilowatt hours is it equalizes everything out. If you look at our hairdryer equation, we only used a hairdryer for 10 minutes every day, but it came out to be 36.5 kilowatt hours for a whole year. A little light bulb on your front porch is going to be 43.2 kilowatt hours in 1 month. So you can imagine if you multiply that by 12, that's actually a lot of kilowatt hours in a year, even though that light bulb is only 600 watts and the hairdryer was 600 watts. So kilowatt hours are kind of interesting, and they help you compare things better than just looking at the wattage by itself. Our last step is to take the kilowatt hours and we're going to multiply it by that cost. So 43.2 kilowatt hours times, and I'm going to put this as a decimal. That's my 10 cents written as a decimal. If you want to keep it as 10, you can. Your answer is going to be in cents, and then that's per kilowatt hour. So you end up with $4.32 is your answer. If you did that in cents and you just said the 43.2 times 10, you would have gotten 432 cents, which is fine, but you just, to be a little bit more useful number, it should probably be in dollars, because I know last time I went to Burger King, and if they asked me for 432 cents, I would have been like, what? Alright guys, I hope that helps, and you study hard, work hard, and we will do the test before I see you again. Bye!